So 6G is geometric series. And again, we're going to split it up. I'll zoom in on this in just a second here into the finite geometric series and the infinite geometric series. And for your stat box, I kind of did it a little bit differently because I'm sort of really splitting it up into the finite and the infinite. I'm hitting the stat box twice. We're going to talk about finite series with the stat box, and then we'll talk about the infinite series with the stat box. And I'm also really going to clearly tell you when we switch from finite to infinite as well. So just kind of keep that in mind. There's different formulas for each type. Should we get the lights? All right, we ready? So G1's first, and it's all about the geometric series. So the geometric series is the sum of the terms in a geometric sequence. So yesterday we worked with the sum of the terms of an arithmetic sequence. Today it's geometric. So today we don't have a common difference. Today we have a common ratio because we're multiplying to get to our next number. Just like yesterday, we can only, for this first part, we're just taking a look at finite. Now, it turns out we can do infinite with this type, but that's going to be the second part of the notes. So the first part, we're just going to look at finite geometric series. We will have those two formulas that we already previewed in the note packet, but you'll notice that these variables that we will be plugging in for are the same as they have been. Like this right here in this white box is nothing new. The capital S stands for that sum. Notice it's S sub n, and n stands for the last term number. So if we are adding up the first 15 terms, it's S sub 10, or S sub 15. So we're only looking at a certain number. U sub 1 is still the first term, and R is still the common ratio. So again, like for the first part, we're not going to infinity. We're only going to add the first however many terms. We all good? Okay. So these are both formulas, the ones that we looked at. I find myself having a preference of one over the other, though I'm really not sure why. I have no reason for it. I kind of want to switch, but very, very similar as mentioned. They both have the first term outside of the parentheses, and then the order gets a little different. So depending on which formula you want to use, you will take the common ratio to the term number, subtract 1, so you have to do all of that, do the power, subtract, and then times it by your first term. And then in the denominator, it's the common ratio minus 1. So you can use that formula. And then if you want, the other way is just you do 1 minus r to the nth power and then 1 minus r. So works kind of the same way. You have to do the power, do the subtraction, and then multiply if you want to do it that way. Again, I don't really see a difference. I don't really see a reason to use one or the other. Maybe if you're like trying to keep positive numbers or something, they could see that happening, but I don't know, it's really not that big a deal. So we're going to do two different examples. One's going to be sort of like the normal example, and one is going to be writing a formula, or like a general formula. So are there questions about the formula before we keep going? Okay. So here we go for that first example. We're going to find the sum of the series. So I have 6 minus 3 plus 1 1/2 minus 3/4 to 15 terms. So I'm going to add the first 15 terms in this series. So we're going to kind of take the same approach as we did yesterday, where we can find the first term, we can find the term number, and we can find the common ratio. So kind of just like yesterday, we were like, okay, let's find all the things we need, then we can plug them in. So I'm hoping you guys will have no issue with telling me the first term. 6, good. First number in that list. What's the term number? Or remember we talked about this yesterday, that n is kind of like how many terms are we adding up on this one? 15. Now the common ratio may or may not be trickier, so I want to take a second to talk about that in more detail. Are we all good at first term and term number? So keep in mind this is a sum, so when I'm looking at this, I should really change these minuses to plus and negative. So like if I just had a list, it would be like 6, -3, 1.5, -3/4. So I just didn't want that like negative sign to throw you off, or that minus sign. Are we okay with that? So what am I multiplying to get to the next term?
-2. Oh wait.
Yeah, -1/2. Now, if you are getting confused, if you don't see that right away, remember, you just have to take a term divided by the term that came before it. So I can just take -3 divided by 6, and I've got -1/2. So if it doesn't come to you right away, no big deal. We've done this before. You just divide. So now that we have all the parts that we need, we can choose a formula. Does anyone have a preference which one we use? Not the second one? The second one? Okay. So that's not the one that I did on my notes, so I'm going to have to think really hard. So if we use the second formula, whoops, let's make sure we get it right. Keep in mind, you can use the first one if you want. Like, it doesn't matter. Also, if you really, really want to use the decimal instead of a fraction, I'm not going to stop you from doing that either. So we can plug all those things in. So it's the sum of the first 15 terms. My first term is 6. I've got 1 minus -1/2 to the 15th power, all over 1 minus -1/2. And so I don't know if this is why Stephen said this, but that's kind of what I was getting at, where I said like positive and negatives. Now we don't have negatives on this one, but well, we will, but we won't, in a way. So if you are going to like plug this all into your calculator or something, be really careful with the way you've got it set up. Make sure you know 15 is the exponent. Otherwise, we can always take -1/2 to the 15th power, and we get something kind of big, right? Like if you just plug in -1/2 to the 15th power, but then you can use your calculators to do 1 minus that. So I end up with 6, and then I'm going to write these all down and we'll talk about it. This big old number here. And then what's in the denominator? 1 minus -1/2. 3/2. All right. Now, you know I've cautioned you guys time and time again of like not rounding too much, but see how many zeros this is? We think about our numerator. What's 6 times this going to be about? 6. Okay, so that's okay. We can do a little bit of rounding there. So I have 6 divided by 3/2. So you can either use a calculator, or if you want to do some long style multiplication or division and multiply by the reciprocal, we end up with 4. So if I add 6 plus -3 plus 1 1/2 plus -3/4 and all those terms all the way to the 15th term, I end up with just 4. Okay. Any questions? Because the next one is a little bit different. The next one's not just like plug and chug calculating, it's just simplifying the formula. Okay. We'll approach it some of the same way, but we're not going to get like a number answer. So it says, find a formula for f sub n. So it's the sum of the first n terms of the series. So it's kind of like, we want to get the formula set up so that I could just like choose different n values and just plug them in rather than like going through the whole thing every time. So in this case, our series is 20, -10, 5, -2.5. And I can start it really the same way I did before with the first term and the common ratio. I'm not going to know n. Like, n is going to stay in my problem. So I want a formula that I can plug n into for n number of terms. So see if you guys can figure out the first term and that common ratio. Did you guys get 20 for the first term? What about the common ratio? It happens to be -1/2 again. That was just a coincidence. So, which formula do you guys want to use? Do you want to stick with the one we already used, or do you want to try the other one? You want to try the other one? Okay. So I'm like, pick one and stick with it. Steven's like, let's do them all. Okay. It really doesn't matter. Plus, what would you do if you were like started to get confused and you were like, oh my goodness, I don't remember what goes where? What would you do? Yes, look at the packet. Like, just look. Like, don't try and memorize it and get confused and put your R's and your 1's in different spots. I don't have the packets over there, not in my hand. Just look at the packet. I have it on here, so I'm gonna look at this so that I don't get anything in the wrong order. So, since we can only plug in for the first term and for the common ratio, we are just going to simplify as much as we can. We aren't going to be able to get like a number answer. So I'll put 20 in for the first term. Then I've got -1/2 to the nth power minus 1. And then -1/2 minus 1. So I am still keeping that same approach. Figuring out what I've got, putting it in the formula. Like I said, we just want to simplify. So we can simplify the denominator. What's -1/2 minus 1? -3/2, yep. Also, there's nothing I can do in this big old parenthesis, by the way. Like, the n, like, I'm not going to distribute that. Like, technically, I could distribute that 20, but that's not really going to simplify it. So I'm going to leave that parenthesis exactly as is. And then I've got -3/2. I can do one more step of simplification, though. What was that? It's not good. I can actually divide that. So I can do 20 divided by 3/2, which is the same as multiplying by the reciprocal. So I can multiply by -2/3. So what happens when we multiply that? -2 times 20 is going to be -40. So I have -40/3, and then my parentheses is all still the same. I did not do anything to that. So that's really as simplified as that one gets. If you have the other formula and you have it turned around, that would be fine too. Like, you could get a slightly different answer if you use the other formula. So don't panic about it. It's going to be fine either way. We're going to hit the stop box and then start talking about infinite geometric series. Do we have any concerns before we do that? looks like we're all good. Okay, this one is just sort of a little bit of a reflection, like which formula do you prefer and why? Light bulb. Anyone else have any odd feelings? Whichever one keeps it positive, so in a way you like it both. I always drawn to the first one. I'm not sure why. I think it's because the variable is like the r's in front. However, I like want to make myself switch to the second one because it's more like the next formula we're gonna look at for memorization purposes. But I don't know. I can't give myself a switch just yet. Again, doesn't matter. You can look at your formula packet. Okay, switching on to G2. So you know there are going to be two different sections in your assignment. So if you want to let yourself know that we are now going to move to G2. So far, what we've talked about is finite geometric series. So we're going to add the first 15 terms, the first 10 terms, the first 100 terms, whatever. Well, it turns out we can actually sometimes calculate an infinite geometric series. There's two different cases. So if I have a common ratio whose absolute value is greater than 1, so like a common ratio of 2 if I'm multiplying by 2, or even a common ratio of like a -3 or something like that if I'm multiplying by -3, that sum is going to be divergent. It is going to get infinitely large, either infinitely large towards positive infinity or infinitely small towards negative infinity. Like it's not going to come to be a number. So if your common ratio is bigger than 1 in a sense, or less than -1, then you can't actually do it. But if your common ratio is between -1 and 1, so like on the previous examples we've done, our common ratio is -1/2, right? So that would work. That would be okay. Or if you had even in the positive, so if you had a ratio of 3/4, so a ratio of 2/5, or anything that's less than 1, our sum actually converges. When you add up all those numbers, even to infinity, it will actually kind of even out to a number. So that's kind of interesting. I think that's kind of interesting. So there is a different yet similar formula for this, and it looks like this. So one thing you'll notice is missing. What is usually in our formulas that we don't see here? N. Because n is the term number, but we don't have a term number because this is to infinity. Like we're adding up all of the terms to infinity, so that's why there's no n here. So it just says s. In your packet, it has a little infinity down here, so don't panic if you see that. In your packet, it has a little infinity. It almost looks like an s because it didn't copy great, but don't worry about that. So for this one, you just take the first term and divide it by 1 minus the common ratio. Again, that common ratio has to be between -1 and 1. It can't be like a big number. Sometimes this is called the limiting sum, so just in case you hear that. Now you can definitely use this formula just like we used it on the last example. So like example 1 that we had where we found the first however many terms was that? I don't have that in front of me right now. 15 terms. Like we could have found that one to infinity if we wanted to. So I just want to let you know you can do sort of normal problems, but there's like a different type of problem that you're going to look at. So our examples are we're going to use the formula, but it's going to start off a little bit differently than we're used to. So probably just because I'm a math teacher, I think this is a little bit interesting. The example is write as a rational number. And the number we have is 0.8. What does that line on top mean? Yeah, repeating. Sustain. Okay. Well, I get it. That makes sense. So it means repeating. So what does rational mean? A rational number? Yeah, like a fraction. So basically, what this question is asking is take this number, 0.8 repeating, and write it as a fraction. Now, does this look like a series? Do I have a bunch of numbers in a list that I'm adding up? No, but I can actually make them. So I know that this means it's 0.888. This is just going on and on, right? So I can actually write that number as a sum of numbers. So I can kind of break it down into different chunks. So I've got this first chunk, which is 0.8. And then I'm going to add the next chunk. Yes, absolutely. Now I took this 8 out, so it becomes 0.08. So there's not an 8 there anymore because I took that one out already. So you can probably guess that I'm going to add the next chunk, right? So it's going to be 0.008 for the next chunk. And I could definitely keep that going. Like I keep going, but I think that's enough. Like if we've got 3 terms, that's enough. Because, well, I want to actually do one other thing, but I had some people second hour do this problem with the decimals and they got the right answer. So if you like really have a thing for decimals, you can try it out. I think it's a little bit easier if we change these into fractions. So without reducing, what's 0.8 as a fraction? Yeah, because we would read it like back in elementary school. We learned to read that as 8/10, so that's 8/10. So what's this one?
100.
And then
8,000.
yeah. So again, for me, it's kind of easier to see what's going on when I use the fractions rather than the decimals. But I'm not trying to say you can't ever use the decimals. I would just caution you a little bit. So I'm running out of space, so I'm going to write it up here. What's that? I do. Thank you. What? Yeah, that was incorrect. Okay, so what's my first term? 8/10. And see, for me, it's easier for me to find my common ratio here. Like, what am I multiplying to get to the next term? If I think about it as a fraction, what am I multiplying to the top to get the next number? Just 1. Well, what am I multiplying to the denominator to get the next number? 10. So for me, it's easier to find the common ratio if I use the fractions. So then I can use the formula, which is the first term over 1 minus the common ratio. Do you see how I almost messed it up? Look at your packets. Look at your packets for these. There's so many formulas, okay? So, and keep in mind, and this is why I'm cautioning with whole use of decimals, is that our final answer should be a fraction, so just be careful. So I've got 8/10 over 1 minus 1/10. So I just plugged in the first term in the common ratio. So I'm going to leave the numerator as 8/10 for a second. I challenge you guys, can anyone subtract the denominator without a calculator? Yeah, how did you do that?
It's really easy.
Why is it so easy?
Because you just think of it as 0.1 otherwise, and then it's.
That's hard to me. What you are saying is hard in my brain.
But like it goes fast through my brain.
Which is, that's good. You should know that. My brain is like, okay, 1 is an easy number to change. I could change 1 into 10/10. 10/10 minus 1/10. Oh, that's just 9/10. That's not bad. What? Oops. You'll be okay. I'm just going to challenge you to try to do those without a calculator. I'm not taking your calculators away. Not in this chapter. That's not happening. I'm just going to challenge you to try that. So back to fractional knowledge. When I divide by a fraction, it's the same as multiplying by what? The reciprocal. So that's going to be 10/10 when I flip it. Or 10/9. Goodness gracious.
You're going crazy.
I am. So then this cancels out nice and cute. And my final answer is 8/9. Because they cancel, because it'd be like 80/90. And then you would divide by 10 to reduce. Okay. Are you guys surviving through this stuff? Okay, well let's try one more like this. Okay, same type of problem, but now it's 0.52 repeat. Yeah, it does. So some of you might be able to jump right to the fractional versions, but if not, we can write this as decimals again by doing those chunks, right? So my first chunk is 0.52. Now my second chunk has to go all the way to the 5.2, so I'm going to have two zeros in here. So I have 0.0052. So it's a little bit different. Yeah, it's not? No. And then if I do a third chunk, just for a good measure, I'm going to have 4 zeros after the decimal point. And again, I did see some people using fractions and getting the right answer. Not using decimals and getting the right answer. I just caution it. So what's this one? 52 hundredths. So this one, it's tenths, hundredths, thousandths, 10,000ths. So I've got 52 10,000ths. Yep. And I'm going to be honest with you, I just start counting zeros, and I'm like, oh, I've got 2 more zeros, so this one's going to have 2 more zeros. Yeah, I got to be honest about that, but yeah, it's millions, pretty sure. Place values were never my strong, so you guys are talking about never learning your fractions. Like, I don't know, place values are a struggle for me. Okay, so what's my first term? And then, okay, what is the common ratio in this one?
1 over 100. Or 1.
Yeah, 100. So noticing like it's got 2 zeros added, so that kind of is our clue. That's going to be 1 times 100. So I'm going to read the formula. Let's see what you guys get on your own for this one. So we've got the first term. We've got the common ratio. Just kind of see if you can work through it. Did I write the formula right? Yep, always check. I was helping someone second hour, and I was looking at the work, and I was like, no, this looks fine. And then I realized that you just forgot to write one part of the formula down. It wasn't working.
Get out of here.
No, don't look at it.
Why? Because it's right?
Oh, I don't know.
It's all right.
Okay.
You get 52.
Oh, I'm in school.
No, I know that there seems like there's a pattern, but that pattern isn't true 100% of the time, so be careful. So kind of like if you wanted to challenge yourself to answer this denominator without a calculator, that would be like 100 100ths minus 1 100th. So 100 minus 1 is 99. So again, it's just a little challenge to yourself. So we've got some canceling, so I end up with 52 99ths is my fraction there, my rational number. Okay, so that's all the notes and all the formulas for the whole chapter. Good, right? I don't know. I'm not sure. All right. The step box is just to have you guys think about what it means for that series to converge, even though it's infinite, and I'm adding up all the numbers. Keep in mind, it kind of fluctuates until it comes to like to one number. That's sort of how I think about that one. Okay, that's fine. Here is your assignment. When is your test?
Friday.
Friday.
Ew.
Friday. 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 Friday.
Like plus one?
Nope.
Can we do it for fun?
You know, we actually thought about